Can you solve this geometry challenge? Here's the question. Given this equilateral triangle, now let's draw perpendicular segment inside of it. Now let's color this for region. Now the area of this yellow region is given as 120 square units, and the area of this pink region is also given as 48 square units. Now the question is, what is the area of this green region and this blue region? Now pause this video right now and see if you can answer this question, because I will show you the answer and the solution in 3, 2, 1. Alright, the answer, the area of this green region is 22 square units, and the area of this blue region is 20 square units. Now the question is, how do we get those results? And this is our solution. Now to answer this kind of question, first thing that we need to do is to name some important points and segments. Now let S be the side of this equilateral triangle. And this segment right over here, let's call this A, this is B, this is Y, and this is Z. And now, this green region, let's call this as G, and this blue shaded region, let's call this as B. Now, let's focus on our figure. If we let this angle right over here be equal to theta, and we know this is 60 degrees, so the remaining angle must be equal to 60 degrees minus theta. Now let's focus on these two right triangle, because take note, using the ratio of areas, if we have two triangles having the same height, then the ratio of their areas must be equal to the ratio of their bases. So given these two right triangles, we can say that 48 over 120 equals the base of 1 over base of 2. If we simplify 48 over 120, we get 2 over 5. In short, base of 1 over base of 2 can be written as 2x over 5x. So the base of 1, this can be written as 2x, and this one is 5x. Now, let's focus to this pink triangle. Using the area of this pink triangle, we know the area of a triangle equals to 1/2 times base times height. Now, we know the area, this is 48, the base is 2x, and we don't know the height. And if we simplify this, we get that 48 equals x times h, or simply the height of this triangle simply equal to 48 over x. So we can set the height equals to 48 over x. Now also, using this right triangle right over here, if we get the tangent of this angle theta, we get that the tangent of angle theta simply equal to 2x over 48 over x, or the opposite side over the adjacent side. Simplify, this will give us 2x squared all over 48. Now, don't simplify this yet, because we will use those 48 later on. Now, let's focus on this yellow triangle. Again, using the tangent function to 60 degrees minus theta, we get that tangent of 60 degrees minus theta equals to 5x over 48 over x. Simplify, this will give us 5x squared over 48. Now, we will use these two results, because take note, we have an identity that says that if we have tangent A plus B, this is equal to tangent of A plus tangent of B all over 1 minus tangent of A times tangent of B. So, we can say, using this, we have tangent of 60 degrees minus theta plus theta simply equal to tangent of 60 degrees minus theta plus tangent theta over 1 minus tangent of 60 degrees minus theta times tangent of theta. And we know the values of those, because tangent of 60 degrees minus theta is 5x squared over 48, while tangent theta simply equal to 2x squared all over 48. Therefore, this equation becomes tangent of 60 degrees equals 5x squared over 48 plus 2x squared over 48 all over 1 minus 5x squared over 48 times 2x squared over 48. Now we know tangent of 60 degrees is simply equal to square root of 3. Now simplify the numerator and the denominator. And now let's focus on this result. And what we're going to do is to find the value of x squared. So a little bit of algebra. Let's simplify the denominator. Now simplify the right hand side, multiply the right hand side, Now cross multiply, equate this to 0. Now take note that we can factor this out nicely as 10x squared minus 48 times square root of 3 multiplied by square root of 3x squared plus 48. Now let's double check this factor. The outer 10x squared times 48 is 480x squared, and the middle term is negative 48 times 3 or negative 144 squared. If we subtract these two, we get 336x squared, which is our middle term. In short, our factor is absolutely correct. Now, we know that x is not an imaginary number. In short, the factor that will give us a real value of x is this factor 10x squared minus 48 times square root of 3 equals 0. Solving for the value of x squared, we get that x squared equals 48 times square root of 3 all over 10. Now, given this equation, we get that x squared equals 48 times square root of 3 all over 10. Now, we will use this result and let's focus on this yellow right triangle. Because using Pythagorean theorem in this right triangle, we get that x squared equals 5x raised to the power of 2 plus 48 over x raised to the power of 2. Simplify. We have 25x squared plus 48 squared all over x squared, and we know the value of x squared. This is 48 times square root of 3 divided by 10. Substitute the value of x, and we have 25 times 48 times square root of 3 over 10 plus 48 squared times the reciprocal of x squared, which is 10 over 48 times square root of 3. Simplify this, we get 120 times square root of 3 plus 160 times square root of 3. And if we add those values, we get 280 times square root of 3, which is our s squared. Now, let's set aside this result. Because, take note, the area of this whole equilateral triangle can be computed using this formula s squared times square root of 3 over 4, wherein this s squared, or this s, is the side length of our triangle. Now, we know the value of s squared. This is 280 times square root of 3. Now, simplify. This becomes 210. Now, we now know the area of the whole equilateral triangle. This is 210 square units. But we want the value of g and b. Now, notice that the area of the whole equilateral triangle is also equal to b plus g plus 48 plus 120. In short, we can simplify this as b plus g plus 168 equals 210. It follows that b plus g equals 42. Now, let's set aside this result and let's find the value of b and g. And to do that, what we're going to do is to use again the ratio of areas. So take note, b plus g over 48 plus 120 simply equal to a over b. Now, we know the value of b plus g. This is 42. We don't know the value of b and the value of g, but we know b plus g. This is equal to 42. Now, 42 over 68, this will give us 1 over 4. We now know the value of a over b, which is 1 over 4. Now, in this case, we will use one theorem, and this is the Menelau's theorem. So, in this figure, we can say that AF over CF times CE over EB times BD times DA equals 1. So, using this concept, to this figure, we can say that A plus B over B times 2x over 5x times z over y equals 1. Now, simplify this. This a plus b over b, we can rewrite this as a over b plus b over b, and this 2x over 5x, this becomes 2 over 5. Now, we know the value of a over b. This is 1 over 4. Now, 1 over 4 plus 1, this will give us 5 over 4. Cancel 5, and we have 1 over 2. In short, z over y simply equal to 2. Alright, now, we will use again the ratio of areas. Because, take note, b plus 120 over G plus 48 simply equal to Z over Y because they have the same height. Now, we know the value of Z over Y. This is simply equal to 2. Now, cross multiply. We have B plus 120 equals 2G plus 96. And we know the value of G, given this equation, B plus G equals 42. So B is just 42 minus G. Now, simplify this equation, we get 66 equals 3G. Divide both sides by 3, we get that G equals 22. Now, since G is equal to 22 and B plus G is 42, we can say that B simply equal to 20. In short, the area of this green region is 22 square units and the area of this blue region is 20 square units. Therefore, given this figure, then we get that the value of this green region simply equal to 22 square units and the area of this blue shaded region simply equal to 20 square units. And as always, we are done.